All right, let's do example number 8. Find the limit as x approaches 1 of x squared minus 2x plus 1 over x minus 1 cubed. Remember, anytime I give you a limit problem, the very first thing you want to do is your direct substitution. So let's plug in a 1 and see what happens. When I plug in a 1, 1 squared is 1. 2 times 1 is negative 2, so 1 minus 2 is negative 1. Negative 1 plus 1 is 0. 1 minus 1 is 0, and 0 cubed is 0. So I end up getting 0 over 0. Because I have a 0 over 0, I know there's a hole. But just because there's a hole doesn't mean that the limit doesn't exist. So let's figure out where that hole is and see where we're at as we approach 1. Let's go ahead and get rid of the hole. It looks like this one is factorable. So let's go ahead and factor the numerator. I factored the numerator into an x minus 1 and an x minus 1. Now my denominator says x minus 1 cubed. That really means I have 3 of those factors. X minus 1 times another x minus 1 times another x minus 1. If you noticed, I just got rid of the hole that we have at x equals 1. And so now I have a new equation that has a 1 in the numerator and an x minus 1 still left in the denominator. So now I can figure out where we're at on our path because I've just gotten rid of the hole at x equals 1. So I'm going to do my direct substitution again to see where we're at, even though there's a hole there. If I plug in a 1, I ended up getting 1 over 0. That's a little bit different than 0 over 0. Do you remember what it means when we have a number over 0? What's happening at 1? Yeah, there happens to be a vertical asymptote there. So imagine what that graph is going to look like. Yeah, there might be a hole at 1, but there's really a big old vertical asymptote there. And so technically, our limit doesn't exist. Well, does it really not exist? Or does it just both shoot up to positive infinity, or do they both shoot down to negative infinity? So what you would need to do is look at a picture of this graph or do a table of values for right now. I'll show you another technique later. But if we're approaching x equals 1 and we know there's a vertical asymptote there, if we look at the picture of this graph, well, the picture looks like this. One of them goes down from the left, and then if I'm approaching one from the right, it goes up. And so if the left side goes down and the right side shoots up as we approach this vertical asymptote, then my limit truly doesn't exist. If they both went up and approached positive infinity, we would have said that the limit approaches positive infinity. Or if they both went down, we could have said that the limit approaches negative infinity. But since one of them goes down and one of them goes up, and I only know that because I looked at the graph on my calculator, I know that the limit truly does not exist.